In this lesson, we are going to graph hyperbolas. Hyperbolas have, equation-wise, pretty similar look to ellipses. And you're going to see that when we start to graph some of the things, it's going to have a very, very similar feel to ellipses. Biggest difference is, rather than an addition sign between them, you're going to be subtracting the two. And your center is still going to come from the left and right shift from your H, the up and down shift from your K. So that's going to be your center. And then whatever's underneath your X's, that's always going to be your left and right from the center. This is still going to be your up and down, but you're going to have to square root both of those. So you'll have to turn your A squared into A, and that's going to be your left and right from the center. And then your B is going to be your up and down from the center. So all of that still matches your ellipse. So let's say we have our centers here, and we go out A, and we go up B. Okay, so whatever we go up, we would go down. Whatever we go right, we would go left. So the difference is that if you had an ellipse, you would have your ellipse. But on a hyperbola, it's definitely a different looking graph. What this does is helps you build a box. And that box is going to line up asymptotes for you. So we'll build a box. And this graph is not considered a vertical hyperbola. It's not because an ellipse, you would have had a vertical ellipse because your B values would have been bigger than your A according to what I just kind of sketched. But that's not going to be the case on this. Your hyperbola is going to be dictated upon whether the X's are first and you're subtracting the Y's, or in the second one you have the Y's and you're subtracting the X's. So if the Y's are positive, then you're going to have a vertical. If the X's are positive, you're going to have a horizontal. So what does that mean? Well, once you draw your box, the box helps you line up asymptotes. So you make an asymptote from corner to corner through the center, and then you make another asymptote corner to corner through the center. And so I have that drawn on both pictures. And so if you have X's subtracting Y's, then you're going to have a horizontal hyperbola. So your hyperbola looks like this and this. So it kind of hugs the asymptote, breaks off, hits that corner, which is a vertice, and then comes off. So that's a vertice. That's a vertice. So you have two vertices. So it had nothing to do with which side was wider or longer or anything like that. It just has to do with the fact that it's X's being subtracted by Y's as opposed to Y's being subtracted with X's. This graph is going to look like this, where it's going to come from the top, hit that vertex and bounce back up, or it's going to come from the bottom, hit the vertex and come back down. All right, so you still have two vertices. They're just top and bottom versus kind of the left and right. All right, so then the last part of this is you need to find your focal points because there's still reflective properties that the parabola and the ellipse have. And so your focal points are going to be here, kind of in this parabola-ish piece. So it kind of makes sense that it's going to be sitting here. To find it, it's very similar to the ellipse, but to find it, you're going to have a c-squared value again. But rather than finding the difference between your denominators here, you're going to be adding them together. So the order doesn't matter. You're going to add those two denominators together, and then your c value is going to be the square root of that. So the c is going to be your distance to the foci. So whatever that distance is, that total distance, so if you had it here and you had it here, that total distance all the way across is your c value. All right, so whatever that is. So your c value should be bigger than individually the a and the b because you're adding them together. So it definitely should be further outside. And then if you had your up and down one, you're looking at having the focal points here, potentially here, and again that distance all the way down would be C. All right, so so if you notice, the B value kind of still flows through with the Y's. I personally keep the B value is always my up and down, so I just always consider it under my Y's. Not all books and things do it that way, but I like to just keep it consistent. That way I don't care. Whatever's under my Y's, I refer as B's because those are going to be my up and downs, and whatever's under my X's, regardless of where they're at, are going to be my left and right values. All right, so it doesn't really matter. So we have it here or we have it under here. So that covers it. The one other thing that you'll have to do is also you'll most likely have to figure out what the equation of these asymptotes are. So the equations of these are linear equations. Your A's and B's actually kind of connect to your slopes, and then you'll have to do a little bit of math to typically figure out what your y-intercepts are. All right, so that is a little bit of an introduction to hyperbolas, and then we'll spend some practice graphing them.